All right, here we go. Everyone looking up here? Headphones, please. All right. Okay. All right. Well, we got a new learning target. We're going to graph systems of equations. A system of equations, plural. It just means there's more than one line. And yesterday, we know that when they touch, that's your solution, right? Two lines intersect, solution. That's the very bare basics of systems. This is Unit 4 stuff, right? By the way, how we doing? No Shave November. Don't forget. Mas Badaba. All right. Well, anyways, quiz coming up next week. And don't forget to finish yesterday's assignment. No paper. It was online. I posted it on Google Classroom. It's a Go formative. You should have done that yesterday, but if you were absent or you didn't finish, it's there in Google Classroom. You should do it. All right, so just like we've done before, you can go to Desmos. All right, to Desmos, and we're going to graph these two lines. It's kind of like they're not already there. There we go. So if I graph y equals 2, I'm going to literally type y equals 2. Okay, now whenever it's y equals a number, that's going to be a horizontal line that hits the y-axis. Okay, so you see this green line here? It goes through 2. Okay, and then we're going to graph x equals negative 5. We're literally just going to write. Why does it do that? Okay, x equals negative 5. So here we go. X equals sign negative 5. When it's x equals a number, that's going to be a vertical line that goes through the x-axis at negative 5. So here's the question. What is the intersection point? It touches right here. So if you click it, it'll put a dot there, the point. Negative 5 comma 2 is the answer, which is the numbers we had for those vertical and horizontal lines, right? So kind of no surprise there, but you know how to type in equations just the way they are. Tell me where they cross. That is the solution intersection point. Now, today we're going to do this by hand. Yesterday we kind of did it digitally. Today we're doing it by hand on paper. Okay. Here, can y'all two scoot back just a little to that line? You scoot back. Y'all have like a little scoot back. And you. So close. There's the line. Yes. All right. There you go. There you go. All right. Here we go. So our notes today, our assignment is on graphing linear systems. Okay. So we want to review the steps to graph linear equations. We talked about it yesterday a little bit. We've been talking about it. We're gonna reinforce it. Okay. So here we go. All right. Number 1, step 1. First, we identify the slope, the y-intercept, and the slope. Right. So whenever you have a graph, you have mx plus b. If it's y equals, you know the y-intercept is b. Right. You know m is the slope. Okay. So when you graph it, the first thing you plot is the y-intercept. You start at the b, for that stands for beginning. That's what I say. Then you use the slope, rise over run, your m value, to get the next point, and then you're going to use these nice straight edges to make nice straight lines. So make sure we got these. Again, when you make lines, you want them to be straight because when they intersect, if you make weird curved lines, they may intersect in the wrong spot. You don't want that to happen, right? So here we go. Number one, graph the following equations on the same graph. Y equals x minus 6. What's the m? Okay, it's in front of the x, but if there's nothing there, what number is implied in front of x? 1, right? So when you see x, that means 1x, but even more than that, like we have up here, any whole number is also over 1, right? The reason why that matters is because slope is rise over run. I would like to have a fraction. So when you have x, that means 1 over 1. Up 1, right 1. 1 over 1x, okay? So what's my m? I like to leave it as a fraction, 1 over 1. What's my b value here? Kinda. -6. So don't forget the sign in front of it. Cool? So it is 6 with a negative. Okay, -6. That matters because what do we graph first, the m or the b? B is where you begin, right? So you graph the b first. So -6 on this y-axis. Let's find -6. It's not up here. That's +6. It's down here. 1, 2, 3, 4, 5. -6. Put a point there. Y'all got to know which way is negative. You can't forget the negative signs. Please, please, please. After we plot B, now we're going to use the M, rise over run. Rise 1, run 1. Rise 1, run 1. So starting at -6, up 1, right 1, because they're positive. Up 1, right 1. Up 1, right 1. Okay. You can do the pattern a few times and then use your straight edge to connect it and make a nice straight line. Okay. And I like to put arrowheads because it keeps going and going and going. Okay, so you made a nice straight line at -6, going up 1, right 1. What about the next line? What's the m? What's in front of x? -2. Remember, any whole number is over 1. If it helps you, write it like that. But you got to know it's rise over run. It's a fraction. Whole numbers are over 1. And then my b value is what? 3. Okay? I'm going to ask this every time. What do I graph first, the m or the b? B for beginning. So the b value is 3. Put a 3 on the y-axis right here. +3 is up 3 from 0. Okay? So then I'm going to plot that 3. Now, my slope is -2 over 1, right? So don't forget over 1. So is it going up or down? Negative means down 2, and then over to the right 1. Always to the right. So here we go. Down 2, right 1. Let's keep the pattern going. Down 2, over 1. Down 2. Hey, you can see where it's going to cross if you keep the pattern going. -2 over 1. Down 2, right 1, down 2, right 1, down 2, right 1. Boom. All right. So remember yesterday we talked about when the lines cross? That's the intersection point. That's the solution. That's what I'm looking for. I want to see these collide. Now, at what point do they intersect? What is this point? So I need the x, comma, y value of that point. So you tell me, what's the x value? So it goes from 0, does it go left or right? This is to the right, how much? So the x value is 3, and then it goes down 3, which means it's negative. Yeah, so 3 to the right means +3. Down 3 means -3. Do you see how to plot or write the coordinate of a plotted point? X before y, horizontal before vertical. Don't forget which way is negative. Left is negative for the x, down is negative for the y. Okie dokie, that's called the solution. Underline that thing, please. Okay. Does anyone still need this first one? We're going to do another one that's a little bit different. Going once, going twice. You still need it? Okay. So while we're finishing that one, think about the next one. Can you start graphing this point? So what's the m down here? Negative 1/2. Y'all see that in front of the x? What's the b? 6. Okay. What do we graph first, the m or the b? The b. So the b is positive 6. So 1, 2, 3, 4, 5, 6 up. And then if I have a slope of negative 1/2, is that going up or down? Down 1/2. So down 1 over to the right 2. Rise is up and down. Over, run is left and right. Okay. It always runs right, so really the rise is up or down, the run is right. So you can do that pattern again, down 1, right 2. Heck, you can do it again if you want. Make a couple points and use your nice protractor, straight edge to make a nice straight line. Okay. Now, what about the next one? The m in front of x is negative 1/2. The b after the x is positive, so just regular old 2. Let's graph that one. M or B? What do I graph first? B for beginning, right? So plot that to y-axis right there. And then I'm going to rise over run. The rise is negative 1, which means down 1 over 2 to the right 1, 2. Down 1 over 2. Down 1 over 2. What do you notice about these lines? They don't touch, right? What do you call this? Starts with a P. Parallel lines. They don't intersect, right? Well, that's weird. So they don't touch, they don't cross, they don't intersect. So what do you think the solution is? If there is no intersection, there is no solution, okay? No solution. That's how you could say that. Some would say it does not exist. Error, okay? But you get the idea. No solution if they're parallel. By the way, parallel lines don't intersect, they have the same slope. Write that down. You can tell from the equation before you graph it. Same slope, parallel lines. By the way, Rady's gone. Rest in peace, Rady. Halloween accident. Okay. All right. Well, anyways, y'all ready for the last one? Flip it over. All right. Here we go. M, 2/3. B, 5. M, 4/6. B, 5. Okay. What do we graph? M or B? B, right? The B is 5, so 1, 2, 3, 4, 5. Put a point. And then rise over run. Rise 2, run 3. I'm just going to use those 2 points, and I'm going to connect the dots. Okay, there's line number 1. And then my other line, my y-intercept is 5, and then my slope is 4/6. So let's go ahead and plot a point of 5. Oh, hey, look, there's already a place where they're going to overlap, right? And then 4/6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. It goes up to the right because it's positive, and that point is also on the line. And then when I connect them, awkward, what do you notice? One word to describe these two lines. They are what would you describe these two lines as? What do you think? They are, hey, they're the same. Okay. Another way to say it is that they could be, I don't know, on top of each other, equal. I mean, it looks like one line, doesn't it? But it's really, I drew it, and then I drew it again. They're different equations, obviously, a little bit. So everybody, check it out. If they're overlapping like this, okay, the math word is called, write this down, coinciding. Y'all ever heard the word coincident? That's a coincidence. Like when you talk about something and then it just randomly happens. Like if I said, Mr. Hillbig works here, and then I look out the window, he walks by, I'm like, that's crazy. You know, that's a coincidence because it happened at the same time, right? So same idea. Coinciding are coincident lines at the same exact spot. Okay, now here's a question. We said, hey, there's a point that they're touching. There's a point that they're touching. What do you think the solution is? Is there any place that they're not touching? No. Or to say it another way, everywhere on the line, it's intersecting because it's always overlapping, right? So how do we say this? What is the solution? You would say it like this: all real numbers. Doesn't that make sense? That if it's always intersecting, it's all the numbers you could ever think of. And if you haven't learned this in this class, I can't remember, but the symbol is like a weird looking R with like two lines. Okay? All real numbers. Weird R, bold R, double line R, whatever you want to call it. Okay? Okay, so those are called coinciding lines. They're the exact same. They intersect everywhere. Okay? Now we got to fill out this bottom part, so if you're still getting that, get that real quick. Look at the bottom left, okay? See these two lines? How many times do they cross? This will be done faster if y'all just help me out. How many times do they cross? One time. So how many solutions? If it touches once, there is one solution. Cool? Okay, this middle box, okay, if they look like they don't cross, they have the same slope, well, how many times do they cross? 0 times. How many solutions? 0 solutions, okay? So again, does not exist. Solution means there are 0 solutions. I am not saying that the solution is 0. I want everyone to hear me say that. The solution is not 0. There are 0 many solutions. Not trying to be confusing, but that's precise. Okay, look. Now this next one looks like just one line, but like we just talked about, they're overlapping. They're coinciding. Okay. So if they're coinciding, how many times do the lines cross? All real numbers, right? Now here's another way to say this. The system has infinitely many solutions. Infinitely many mini solutions. Cool. Okay, so I'm going to give you an assignment on this. You've got time today. It's a shorter class period due to Thursday. My suggestion is finish it today because tomorrow you'll still have time for this, technically. But you might need to be working on corrections tomorrow or missing work because I'm going to give you an updated grade tomorrow for sure. Cool? So these are coming around. Here we go.